recording. The difference between geometric and arithmetic. Arithmetic, we add or subtract. So geometric, we multiply or divide, but we're not going to ever divide. So instead of dividing by a whole number, we're going to multiply by its reciprocal. We'll see what that looks like in a minute. All right. So, since it is multiplication, it will look like this. Right above here, though, I also want you to write function notation. So f of n is equal to f sub 1, or f of 1, times, what is r? Well, r is your common ratio. Okay, let's make that a little prettier. Let's use a box ratio. Common ratio. No, we had a common difference when we were adding. Here we have a common ratio. It's what we're multiplying by. Okay. So r to the power of n minus 1. So the only difference is we're looking at r instead of b, and we're multiplying instead of adding. Okay. Questions so far? All right. So here's some examples of some geometric sequences. So let's look at the one towards the bottom, 3, 12, 48, 192. So you can see the numbers get big quick because we're multiplying. When you add, the numbers don't get as big as fast. So 3 times 4 is 12, times 4 is 48, times 4 is 192, etc. Your common ratio could be a negative. So if you're multiplying by a negative, it's going to flip-flop depending on what your first number is. In this case, it's negative. So then goes positive, then goes negative, then goes positive, then goes negative, and I'm going to keep going. The numbers will not always get bigger because if my common ratio is smaller than 1, the numbers will get smaller. How do I figure my common ratio? Take any two numbers and divide them. Any two numbers that are consecutive in order. So they got 2/3 here by dividing the 2 by the 3. If you divide 16/3 by 8/9, or 16/27 by 8/9, you'll also get 2/3. Okay. So we have the recursive rule still around. So that's the recursive rule as function notation. Let's also write it with non-function notation. So a sub n, recursive rule, a sub 1, let's start with 1, okay, equals some number. Well, I'll just put a number. Semicolon, a sub n equals a sub n minus 1, whoopsies, minus 1 times r. Okay. Now the difference, I'm not sure why. Yeah, the r should be higher. I'm not sure why in this case. I don't know, maybe I just forgot it last time. But they want you to define this for a specific set of numbers. So we are only going to use this when when n, for n greater than or equal to. So if you want it greater than or equal to, I know there's a way to do it. Well, I'll just do greater than, and if you just take equal to, underline it, greater than or equal to, control U. Yeah, look at that, worked. Okay. 2. So we don't start using it until after you move away from the first term. So I don't want that one underlined. So recursive rule and explicit rule. That's the new stuff. So we're multiplying instead of adding. That's what's new. The numbers are going to get bigger fast or smaller fast. So probably going to be using Desmos a little bit more than you did for the other one. No. Yes. Questions? All right, let's jump right into it. Go to the second page. Look at the first sequence. So I'm going to make a big old text box, and we're going to start with the recursive because I think the recursive is a good way to build onto the explicit. So recursive rule. We're going to write it both ways as a function and with subscript notation. So let's start with, let's say subscript. Subscript. Okay, and then tab over a couple times. So since we're starting with 0, this would be a sub 0. So we're in a text box. So to get an equation in a text box, look, this is a visual thing. Gotta look up here at the left of x. So a sub, remember this top row isn't the actual number. it's the position of the number. So my 0th term, that's why there's 0, is equal to 3. Semicolon. A sub n equals a sub n minus 1 times, and then I have to find my common ratio. So from 3 to 6, from 6 to 12, 12 to 24. Remember, we're not adding, we are multiplying. We're multiplying by 2, okay, each time. So come back here, and that is a 2. We need to define what numbers we're using this for. We don't start using this, so I'm outside my equation box for n greater than or equal to, not 2 this time, because my first term after my 0th term is my that. Okay. So I'm going to make an equation box in here. No, it's not going to let me make the equation box this way. N greater than or equal to uno. We don't start using it until after we move from the 0th term. Okay, and that's the subscript version of that. Questions so far? Okay, hit enter a couple times. Up just a hair. There we go. And type in function. So same concept. Now we're going to use function notation. So equation editor. F of n, or I'm sorry, not f of n, f of 0, because that's our first number. Equals, oopsies, back, close it, equals 3, semicolon, f of n equals f of n minus 1. Remember, f of n and f of n minus 1, a of n and a of n minus 1 just means to get my current number, I need to start with my prior number. F of n minus 1 just means prior number. And I'm multiplying by 2. If you put the 2 in front of the f, that's okay too. I don't care where you put it. Just make sure it's clear that it's not anywhere between the f and the parentheses or inside the parentheses. And then just like the other part, we're still finding this only for numbers outside and bigger than 1. So FOR, space, equation editor, n greater than or equal to 1. And that is the recursive rule. The recursive rule is kind of clunky, so we use it as a building block to create the explicit rule. So let's make a different text box. I want to make a pretty green color. So explicit rule. And we're going to start with the subscript notation. So subscript. Copy. Tab, tab, tab. A sub n. Oopsies. Equation editor. A sub n equals my first number, which is from right here. That's my 3. Times my common ratio, which is right there. That's my 2. Raised to the power of just n. Just like we had for arithmetic sequences, when my first term in the sequence is the 0th term, I don't need n minus 1. Okay.
But if it was anything besides it?
And yep. Okay. So that's subscript notation, function notation, same idea. Function. Tab, 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 tab. F of n. F of n equals my first number. Everything else on the right-hand side is the same. Does this look familiar at all? These equations in this explicit rule. It should look familiar, shouldn't they? A little bit. What do they look like? Not slow. Spent about 2.5 weeks doing these, beginning of January. Santiago, they're exponential functions. So, a geometric sequence, just like we talked about arithmetic sequences being linear functions, Geometric sequence is really just a representation of an exponential function. Sequence. I hate typing one-handed. Is a version of an exponential function. All the stuff that you know about exponential functions still holds true. And we're going to use some of the things that we used when we did exponential functions prior. Prompts. Hold down. Go to the next one. I'm not going to make you do it all 4 ways this time. I only wanted you to do it once. Okay. So, Scott, you choose function or subscript notation on the next one. Function. Okay. You good? Good. You got it? Okay. So we're going to use function notation. So let's start with the recursive rule. I want you to take a few moments and determine what the function notation would look like for the recursive rule here. Use the other one as a model.
I think this is okay.
So Scott said function notation, so that means I start with the letter F. So I'm going to hit enter a couple times here. Start with letter F. F of n. F of 1, because with recursive, we need to know what the first number is. Is it 1?
No.
Ooh, 1/25. Okay, so 1/25. Okay. Semicolon. F of n, and this will always be the case. It's always f of n equals f of n minus 1, which means my current number is equal to my prior number. The way I show prior numbers, f of n minus 1 times, I'm having issues with typing, my common ratio. So it might be hard for you to figure out what the common ratio is until you get right here. You should be able to figure out, okay, really all you're doing is you take 2 consecutive numbers. So 1/5 divided by 1/25 might be a little hard for you, but 5 divided by 1 should not be hard. So the common ratio is indeed 5. Okay, I'm going to go outside there. 4 n greater than or equal to 2. So this doesn't start working until we go to the second number. And the reason I'm kind of hitting this harder now is I'm going to take a look at Galileo. I remember in prior years, everything looks exactly the same, except guess what? This number right here, they changed. One says 1 and one says 2.
Always gonna be 2.
Nope. Okay, take a look at the prior one. Oh, see, that was 1.
Okay.
Because we started with
0.
0. Okay, so if it starts with 0, it's 1. If it starts with 1, it's 2. Okay? All right.
Second number.
Just whatever the second term is. All right, so that's my recursive rule. Going to the right, going to the right, going to the right, right. Why does it take me so long? Okay, explicit rule. All right, Denise, help me out. What do I start with? Okay.
1/25.
Okay, slow down. So f of n, because we're looking at the actual function now. 1/25. Go ahead.
Times 5.
Times 5.
To the power n.
So close. Since we're starting with the first term, we need the minus 1 there because this doesn't. The way we show it with the explicit rule, this is actually using the same rule as we're using here, but we don't start using it until the second number because 2 minus 1 is 1. Okay. So this whole n minus 2, n greater than 2 is built into the actual function itself. So one thing I'm not sure about, but let's just kind of see if we can do this, is I'm not sure if they're going to show it this way or, notice they have something in common. What do they have in common? That's got a 5, and that's got a 25, and 25 is just 5 squared, okay? So another way that you might be able to write this, and I'm not sure how it's going to be presented, so I want to make sure we hit all the bases here. So f of n equals 1/5 squared. Is there another way we can write 1/5 squared? 5 to the -2. Okay, so 5 to the -2. And then everything else stays the same. But why would I do that? Why would I possibly make you do that? So instead of 2 5s, I can just write 1. So another way you could write this is 5 to the power of, whoopsies, not 5 to the ampersand, 5 to the power of n minus 1. Is it 2? Is it 3? Is it positive 1? Negative 2 minus 1 is negative 3. Okay, questions?
Plus 3.
Nope, minus. I just
Okay.
hit negative 1 too many times. Must have got excited. And then we should kind of check to make sure this works. We didn't do it in the last one, but let's just check. Okay, so let's put in 5 here. So if we put a 5 in there, I'm just going to make another text box over here. Little bitty check. Let's go back to black. So check. They're having a good old time over there. It does. So f of 5. So the answer should be 25. So let's see if this works. Equals 5 to the power of 5 minus 3. What's 5 minus 3? 2. What's 5 squared? 25. So as long as... Nope. As long as this number here matches this number here, you know your answer is correct. Okay. Questions? Move on. Moving on. We're already halfway done, believe it or not.
Oh, it's like 9?
Yeah, it's short. All right. You try to do the whole thing. Let's see. Last time we used function notation, so this time let's use subscript notation. Okay. Subscript notation. We said subscript notation this time. So let's do the recursive first. A sub 1? No, 0, because there's a 0 there. Equals 1/27th. Goes right. A sub n, that's not going to change, equals a sub n minus 1, multiplying by 3. This only works until we start moving after 1. Okay, so for n greater than or equal to 1. Okay, so that's my recursive. Explicit, put the two things together. A sub n equals 1/27th. 27th times 3 to the n minus 1. Just n because we got 0. Hey, look at my common ratio. Look at the number underneath. Do they have something in common? 3. So equals 3 to the power of negative 3 times 3 to the power of n, which means it's just 3 to the n minus 3. Questions? Let's just do a quick check. I won't write this one down. We'll just kind of see if this works. So for my 6th term, 6 minus 3 is 3. 3 to the 3rd power is 27. That works. Okay. I would recommend checking. Highly recommend checking. Because all it takes is one little boo-boo, and you won't see it. And since there's not a lot of work to be shown, how much partial credit can I give for this? Not a whole lot. Okay. All right. Ooh, decimals. Quan's going to like this one better. All right. Okay. And you may choose...
You said I should be clean.
I didn't.
Because I'm a bean and a woman.
Okay, just to let you know, it's being recorded again. Okay. All right. This one's kind of easy, right? Because you're just multiplying by. Good. Okay. I am starting with my first term, so this is for n greater than or equal to dose. And then function notation using explicit rule. Start with a 0.001. 0 in front just to make it be consistent. Times is 0.001 a power of 10?
Yeah.
Indeed it is. 10 to the what power? It's 1/1000th. How many zeros in 1000?
Oh,
3. So what's my power going to be?
Negative 3.
-3. So 10 to the -3 times 10. Oopsies. Well, what happened there? Oh, it's a little gray thing. Times 10 to the power of n minus 1. So -3 minus 1 more is minus 4. Okay. Now let's just double check. 7. Take a look at my last one. My 7th term should be 10 to the 7 minus 4. Well, 7 minus 4 is 3, and 10 to the 3rd power is 1,000. So it works. All right. Next one, you're actually given the recursive rule, and you need to find the 4th term. Okay, so I am going to make a table. Since there is no table function in Kami, we will force a table. Use the text box. I start with the number 27 because that's my first one. I'm sorry. Starting with the number 1, first term, tab over 5 times. 1, 2, 3, 4, 5. 2, 1, 2, 3, 4, 5. 3, 1, 2, 3, 4, 5. 4. Why do I stop at 4? It's a 4th term. Okay? It says right here. 4th term. All right. I'm going to use my shapes tool. I'm going to use my line tool. I'm going to hold my shift key down so I can get a nice, pretty horizontal line. So it's going to be like an open box. We're not going to worry about closing it up. Doesn't have to be perfect. Hold that shift key down to make some vertical lines. So 1st, 2nd, and 3rd, 4th numbers. Okay? All right. Go back to the text box. Go to the 4. Go to the right. Hit enter. First number is 27. My common ratio is 1/3, so they're not getting bigger this time. They're getting smaller. So 27 times 1/3 is the same as 27 divided by 3. 9. 9 divided by 3. Ooh, look. 3 over 3. Creepy. 3 divided by 3. And I'd like you to make this clear that this is the 4th term. So make a little equation box out here. F of 4 equals 1. So we know our answer. Questions? Take a look at the next one when you're done.
Oh, that's easy division.
All right.
And then we got to apply that.
So you've got a rule here. Is this recursive or explicit? This is recursive because they give you the 1st term, and you're just asked to write it as the explicit. That's all.
Let's go ahead.
So since it's already in function notation, let's stick with that. F of n equals my 1st term, which is 1/27. This should look familiar. I think we did a problem just like this. Times, we just, instead, the other one we did, I think, was 3. So this is 1/3. So when your common ratio is a fraction, my recommendation is to put it into a set of parentheses. Oh, sorry. I'll fix that. Right outside to the power of n minus 1 because of the 2. Okay? So you have to pay attention to the number on the outside. And this should be just 27. Okay? And then let's simplify this. The 27. Okay? So I'm going to do a little copy and paste action. Not try to do everything in one step. So paste. Let's change the 27. This is going to look weird because normally we change it into a whole number. We're going to change 27 into a power of 1/3 because that is our common base. So parentheses 1/3. Come on now, divided by 3. So 1/3 to the negative 3 power. So keep going to the right. Parentheses 1/3. Close to the power of n, oopsies, I opened a new one, close to the power of n minus, I got minus 3, minus 1 more is minus 4. Questions? Oh boy, you only got one more. The next one's going to be the hardest. But we've actually done problems similar to this. Hey, Santiago, what type of functions are these? Exponential. So when you look at the next one, look at it not so much as a sequence, but 2 points on an exponential function. Okay? So when you're done this one, take a look at the next one. In order to construct our rule, we need 2 things. We need the first term and the common ratio. Do we have either of those?
No.
No, we don't. Hey, what did we do before when we had a couple of numbers? We made a table. Let's make a table. Okay. All right. So another text box. 1, 1, 2, 3, 4, 5, 2, 1, 2, 3, 4, 5, 3, 1, 2, 3, 4, 5, 4. Can I stop now? No, because they give me the 5th term. 1, 2, 3, 4, 5, 5. Okay. Let's go to the shapes tool. Let's make that horizontal line. Vertical lines to separate each of these. Self-aware?
Yeah, self-aware. Wait, no, because I mean...
What?
What did you say you were?
I'm mid.
What?
I don't explain.
Hey, are you a midfielder?
No, that's not what I mean. Like you're mid is like circle. Like I don't like I mean I guess. Mid. Yeah. Like seeing the shows like mid. Yeah, you're not above below.
Yeah, you're
mid.
Yeah.
Okay. All right. So we got the numbers placed. Yay. Now what? So Ahmad, Santiago, hi. Look up here. All right. So which one are we going to find first? Our first term or our common ratio? You have to find the common ratio, okay? So if I'm going to the right here, ready? It's all about the bunny hops. I go 1 bunny hop. I go 2 bunny hops. I go 3 bunny hops. So how many times am I applying my common ratio? 3 times. So I go over here, and it's not just R. It's going to be R 3 times. So 3R? No, R cubed. Okay? So R cubed is equal to. You always take the number further along down the line. So in this case, the 10, and divide it by the prior number. So 10 80ths. Okay, so take a few moments and solve for R. And once you have solved for the common ratio, check to make sure it works. So start with 80 and apply it forward. And then see if you can figure out your first term, and then create your explicit rule. All right. So, first step, when you're trying to solve, try to start with something simpler. Is there a simpler way to write 10 over 80?
Yes.
1 over 8. Okay, so I'm going to do a little copy and paste action. Control A, Control C, Control V. I'm going to get rid of my zeros because 10 80ths is the same as 1/8. Next, we have to undo the cube root. How do you do that? Log in.
You took the cube root of each side.
Yeah, I just screwed up. I meant to say undo the cube, but you're right. Take the cube root. Whenever you do the one side, do the other. And since it's a fraction, I got to do it 2 places, top and bottom. Okay. So R equals the cube root of 1, which is 1, over the cube root of 8, which is 2. So my common ratio is 1/2. Let's make sure it works. So going to the right, half of 180, or half of 80 is 40. Half of 40 is 20, and half of 20 works out to be the number it actually is supposed to be. If your common ratio, when you plug it in, doesn't make the number equal what is given to you, then it's wrong, and don't go any further. So if we multiply by 1/2 going to the right, you have to divide by 1/2, but we don't like dividing by fractions, so we multiply by the reciprocal. 160. Okay. So my function So in this case, I'm just going to put up here. We're given subscript notation. I'm going to use subscript notation. So A sub n equals 160 times my common ratio, which is a half. Those of you that want to use as fractions, that's fine. To the power of n
N minus 1.
minus 1. Okay?
So what?
You could.
Do we have to?
In this case, I'm not going to,
Let's go.
just because I don't think it's that useful. I'll show it to you, but what you would do here is, if you want to do it, I'm just going to kind of do this by hand. So remember, 16 times 10 gives you 160. So that's 2 to the 4th power times 10 times 1/2 to the n minus 1. So this would be 1/2 to the negative 4. So if I wanted to simplify it, I could. It's 10 times 1/2 n minus 1 minus 4 more. I don't know that that really helps that much. Okay. The reason I like it this way is because it gives you the first term. If you write it like this, you don't even know what the first term is. Okay. I mean, you could figure it out. I mean, if you plug in 1, okay, 1 minus 5 is negative 4, and 1/2 to the negative 4 power is 16, and 16 times 10 works out, but I'm perfectly fine with leaving it like that.
On a test.
I don't know. We'll when we get closer to the test next week, I'll look at Galileo.
Okay.
All right, done.